Now we're going to do here the Laplacian in general. Now the Laplacian, del squared on f, this is operating on a scalar function f. You can think of this as first taking the gradient of f and then taking the divergence of the gradient of f. Now the gradient of f in general here, we have worked this out before in curvilinear coordinates, and our divergence of a vector in curvilinear coordinates is given by this general expression. So what we're going to do is let the a vector be the gradient of f. So in that case, a1 becomes 1 over h1, the partial of f with respect to the first coordinate, q1, and so on. And then we substitute these into the equation where the components a1, a2, and a3 are. So when we do that, we then get this expression here. Let's look at one of them. a1 here is 1 over h1. There's the 1 over h1, and the partial derivative is there, and then you have h2 and h3. Notice that when we group the h's together, we'll have two h's at the top here, 2 and 3, and the 1 is down at the bottom. That agrees with the coordinate q1. And due to the symmetry, these others are going to be similar, 2, 2, 3, 3, and then the other h's here, 1 and 3, since the 2 is down in the denominator there, and so on. So what I would like you to do here for our homework assignment is show that the Laplacian is given by this general formula that we have here, and you're going to basically work this out for Cartesian, cylindrical, and spherical. That's the real assignment here, to get these things from the general formula. This is a wonderful background for theoretical physics and various areas of engineering. It's wonderful to understand this, where it comes from. Now, many years ago, my college professor, Samuel Enzer, had us in Calculus 3 work this out the long way by taking partial derivatives. This is not a bad assignment to do once in your life, so I would recommend it. It really does get you to master partial derivatives. It's the long way to do it, but rewarding to work it out. Well, sign off for now. We'll see you with the next section shortly.